A little over a year ago, a customer brought us an old 327 small block Chevy that had suffered a broken piston skirt in the middle of a burnout. And while he admitted he probably was pushing it a bit hard, what we found during the teardown was one of the most poorly built engines we've seen on this channel. It's amazing the failure wasn't more catastrophic. Regardless, we went a different direction with the customer and built them a 383 stroker. And even though that old 327 probably should have gone to the scrapyard, we just can't stand to let a legendary engine like this suffer that fate.
Okay, Boomer. I see you've dug this 327 back out.
No, you dug the 327 back out because I'd have scrapped that thing.
Am I a closet boomer?
You must be.
This thing was so clapped out from the last builder that...
Well, from probably several last builders.
Several last builders.
Yeah.
It's already 60 over, so we decided we want to revive this thing, even though it's beyond being revived.
Well, that's it. Normally we get a block like this in, it goes in the scrap iron.
We came up with some sleeves because we're going to have to put 8 sleeves in this thing. I went out and bought an expensive crankshaft and aftermarket connecting rods and the whole 9 yards there. But we got to start with getting this block a little bit closer. So
we wanted to experiment a little bit because I have never used a flange sleeve on a block like this.
On a 327.
Yeah.
It is dangerously close to the bolt holes.
Right.
By the time we get this bored out for the sleeve and cut the counter bore for the flange here.
But even if we use just a straight sleeve, below that, what is that top flange, even 1/8 of an inch there? Once you're down 1/8 of an inch, we're the same as if we used just a press fit sleeve.
Yeah, so it shouldn't be that different. In today's video, we're gonna go through getting these installed. We'll have to run to town because I think we'll heat the block and do liquid nitrogen. Haven't fully determined how much press fit we're gonna have on these because we are gonna install them with, Loctite.
We have several means of these being held because they're gonna be held by the flange. If we put a little retaining compound on there, that'll hold them in place. There's gonna be a little bit of a press fit. But I think our biggest thing about putting the retaining compound in the bottom is we may cut through into the water jacket doing this.
There's a very good chance because these are not very thick, especially between the cylinders here. While we spend most of our time working here in the shop, there are times that we do have to take trips into town to pick up parts or supplies, or even make trips with a customer's part to other shops for outsourced labor operations that we aren't capable of doing in our own shop. Keeping all of those items secure and protected is a must, so we trust our AL3 Pro hard tonneau cover from the sponsor of today's video, WorkSport. The AL3 Pro has a low profile and sleek design that protects your gear without sacrificing quality and style, made with extra strong ceramic coated aluminum panels that provide superior scratch and UV resistance. This tough and lightweight design comes fully assembled, installs in under 20 minutes, and is easily removed for instances when you need full access to your bed. The design features a proprietary clamping system with cable-operated quick latches for effortless cargo access. These latches are easily adjusted for the proper fit and securely latch even with the tailgate up. Combined with the locking tailgate, your cargo is completely secure against unauthorized access. In addition, the triple fin side and rear fin seals provide optimal weather protection so you're covered throughout the year. And all of it's covered by an ironclad warranty with lifetime support. We love WorkSport because their products are designed in the US at their advanced R&D facility in Missouri, manufactured in upstate New York, and shipped throughout North America. They're focused on supporting local businesses and manufacturing as they grow and expand in the market. WorkSport has a limited time summer sale, and you can save a total of $240 when you combine it with our special promo code JIMSAUTO at checkout. There's also a site-wide sale on the SC3 and SC4 Pro softcover variants, valid for an additional discount with our code. Do more and go further with WorkSport. Follow the link below and use code JIMSAUTO at checkout to get an additional discount off any cover anytime. Thank you to WorkSport for sponsoring today's video.
You did some sonic testing on this, didn't you?
When I sonic tested it, it was about 100 thousandths thick here, and I can't remember where I came up with this is 4190.
Well, 4187.
So if this is 4187, this bore size is 4060 right now, and there's 100 thousandths extra wall thickness on the block itself. Yeah. So what's the math there?
I'd do it in my head, but I want to show off.
Well, theoretically, that should still leave us 70 thousandths. Or do I need to divide that by 2? Long story short, it's not very thick. I can't think right now.
This sleeve is actually too long. If that was installed, it'd be hanging out the bottom. We did some highly accurate measurements with our Stanley tape measure here. We need a 5 7/8 inch long sleeve, and we're actually 6 3/4.
And a lot of times when we're putting in a straight sleeve, we just put it in too long, and then once it's in, we can trim it off on the top.
Yeah.
But this is a flange sleeve.
With that flange sleeve, we have to put it into the right depth on the top side.
So I came up with this pretty genius setup over here. We thought about using the lathe to trim these off. We don't have quite the right work holding setup to do this in the lathe. So what we came up with is put a 3-jaw chuck, extra chuck from the crankshaft grinder on the boring machine here. And then we're actually setting up on the inside of the sleeve. And we came up with this band here.
It's actually the outside ring of an old harmonic balancer.
Right.
That we bored out to just the right size to fit over the sleeve.
So that fits over the sleeve so that you can really crank down on the chuck here and get this sleeve nice and tight. You can center up on this first one, trim it to length, and we should be able to switch, from one to the next.
One to the next, not even have to recenter or anything. It's just a matter of one after the other. I'm going to come down till I just touch. Okay, I touched off there. I'm going to set my Z that I want to take off 0.875. So let's take this down till I hit 0.
That didn't work.
That didn't work. You got that on the camera?
Oh, yeah.
Okay, that's good. That's the main thing. So we're not quite tight enough.
So is that sleeve toast?
No, we didn't. I don't think we heard anything.
Usually the chuck is spinning, and you're supposed to make sure you don't leave the chuck key in. So maybe you should have left the chuck key in since the chuck is not spinning.
Is it not spinning? It should be left in? Okay, well, we did not hurt anything other than a little embarrassment, and we'll tighten it back up a little tighter this time.
Did you even tighten it? I never tightened it.
Oh, I had it. I had it what I thought was tight enough because I didn't want to overdo it. Surely that's enough to hold it. But then that's what we thought before. We didn't even hurt the cutter. How'd that be? How can that be?
How'd that be?
How'd that be? See, I'm all flustered now. Well, now that makes me even a little more glad. Is that right terminology, right English? More glad that we're doing it here instead in the lathe.
Well, I'm more gladder myself.
Are you more gladder?
That would have been kind of sketchy in the lathe too.
Yeah. 250, and as I come up on 0 here, we'll slow down a little bit. There we are, 0. So that should be 5 7/8 inch length, but I want to put a nice bevel on the inside of that. So I'm going to pull this cutter out. That way, after this is in the block, and this is going to be kind of a guessing by golly till we get it where it looks right to us.
You're doing this so that there's not a sharp edge in case the piston skirt comes down past the bottom of the cylinder in operation.
Right. I want a nice... That's not a nice sound. We've put a couple of O-rings around there. Hopefully it dampens that harmonic we have going on there. I think I've got more than enough there. Remember, I stopped at -100, so 100 beyond where we left off with the cutting the length. I think we can just do 7 more just like that.
5 7/8.
Yeah.
Ish. And again, it's a rough number because we're measuring off a rough casting in the bottom here. By the time we get this all said and done, we're going to have to do grinding on the bottom side too. But at least we're in the right realm.
We're right in the right range. Yeah, definitely right range. Potential spam. Look at the difference here. There's what we took off.
Yeah.
I don't know how that could possibly come out, but it did. Okay, we should touch off at 875. See how close we are. There's 877, and I hear a little bit of cutting going on.
Come loose?
Yeah. That's kind of what I was afraid would happen with all that chattering going on.
Yeah.
Yeah, when things start chattering, all that vibration going through tends to loosen things up on you.
I know this is old school, but maybe you use your cone here to clean up the chattery.
Oh, we could. Let's go ahead and do that.
Okay.
Call it good then.
So we've got our block here on the fixture, and again, we're working with everybody else's work.
Yeah.
And the work on this block was not pretty.
Yeah, and we have no idea how many times it was worked on, but certainly the last time it was worked on was anything but pretty.
And we get comments that we don't usually bash on other people's work. This guy deserved that.
Yeah, whoever did this last time should have his tools and his machinery taken away from him because they just destroyed it.
So you've gone through here and just kind of did some checking to see how far off the cylinders are from each other.
Yeah, I just centered up on each one and took some measurements to kind of see where they were at. I think for the most part, what it looked like, if we center up on this cylinder right here, we will be really close on all the others.
To an average.
To an average,
So we're going to zero on this cylinder, and then you're not going to move the y-axis of the table at all as far as this way and that way.
Right.
But when we move over to these other cylinders, rather than centering up on the existing cylinder like we typically do, if we're not...
you're just trying to clean up a block.
Right. You're going to move over the blueprint bore spacing.
Yeah, we'll move over 4.4 inches to catch this one. From here, we'll move 4.4 inches here, and then 8.8 inches to get the center line of this cylinder. So at the very least, we'll have all the spacing correct from cylinder to cylinder.
We're going to cut just over 6 inches.
Yeah, the sleeve is 5 7/8, and if we cut to 6 inches, that'll give us plenty of room on the bottom so it does not interfere with anything on the bottom or run into it. We'll definitely be supported by the flange on the top. See, we started out 4 inches standard. That block is already 60 over. So I'm going to take 110 thousandths cut with that first one, bring it to 4.170. And then our second cut, I'm going to go to 4.188 and a half, which will give us our press fit for the sleeve. And then with this cutter here, I'm going to cut the counterbore diameter to 4.332. These are 1/8 of an inch on the top, 0.125. Do you think leave 10 thousandths extra, let them stick up, and then we can cut them flush once they're in?
Yeah, let's leave them stick up 10 thou, and then we'll deck it.
So we'll go 4.332 diameter, should give us just a little bit of clearance for the flange to slip down in, and 110 thousandths depth.
With that, we're gonna have 1.5 thousandths press, which is maybe a little bit lighter than we sometimes do on a sleeve, but with it being a flanged sleeve, you're relying on that flange to hold it in place.
We don't have to worry about the press fit holding it in place.
So we'll have the combination. We will have press, then we'll have the retaining compound holding it in place and sealing it in case we hit water.
Yeah. And hopefully with that, we'll induce a little less stress in the block than what you would have if you all of a sudden stuffed 8 sleeves into that block with
3 or 3.5.
Yeah, 3 thousandths plus press fit.
Yep. The first cutter is the big cut, and the second cutter will make a rough cut, see how it measures, and then reset our cutter for the finish cut.
Okay, you sure you got everything right?
No, no. You got this tight?
Everything's tight.
Is it going anywhere?
Everything's bolted down.
I guess I didn't comment. We're fixtured up off of the mains of the block, and then we have a 45-degree triangle or whatever that holds the block so that when we're done, our cylinders should be perpendicular to the center line of the crank.
Cylinders will all be exactly perpendicular to the center line of the crankshaft, and when we're done doing both sides, this bank and this bank will be exactly 90 degrees from each other.
Right. So the only thing that our fixture does not take into account is the camshaft center line.
Yeah.
It's not a perfect fixture, but it's better than some.
Yes. Yeah. Much better than some. Not perfect. If we had unlimited funds, we could update and get something that centers off the center line between the crank and the cam. But
for now, this is what we got.
For now, this is what we've got. And at least we have a perfect 90-degree V when we get done. And we're ready to engage and start.
These sleeves are going to come out a little bit thinner than we sometimes try to have as far as the wall thickness.
Yeah, we're going to be,
We'll be 93 thousandths.
Yeah, wall thickness, which is fine. That'll actually leave some room so someday it could be bored again.
But sometimes you do go a little thicker than that.
That worked for us?
Yeah.
Had Mom make us, had the cook make us dauber here to daub our Loctite on the inside of the cylinder there when we get ready to put the sleeves in. Good job. No. Thank you.
So that'll run down to about 6 inches on the Z. Sounds like it's cutting nice.
Yeah, it's not struggling at all with that cut.
I mean, we've taken way bigger cuts than that.
We've taken way too big a cut.
Yeah, we've definitely pushed the limits on this machine before. $40, $30, $20, $10. Wow. That was right at 6.000.
Really? You know, if we'd have needed that close of tolerances, we'd have never hit it.
That is funny. When you're working with plus or minus 50 thousandths tolerance,
you hit it right on.
You hit it on the money.
What do you think?
What do you think?
I think it looks good. I think that'll be fine.
The nice thing here is we are truly working with what should be a scrap block.
Yeah, it's already scrapped before we even start, so we can't really ruin it.
Yeah, we can't ruin it.
Are we ready?
Let her rip.
Now I think this is going lighter cut. We can probably speed up a little bit.
Real light.
Yeah, that shouldn't be more than about 10 thousandths. Should we go down just about an inch and measure it?
Measure it, maybe? Yeah.
How
many times over the years have you put all 8 sleeves in a block?
Not very many.
Because it's generally not
It's just not.
cost effective.
Yeah.
For Joe Schmo customer.
We need to raise this. Let this go clear on up so we can get the bore gauge in there. Okay, I'm a little bit big.
1.5 big.
Yeah. When I put a cutter in the mic here for the cutter, I'm coming up just shy of 4.178.
And when you set the bore gauge to 4178, that cutter actually cut about 1.5 bigger than 4178.
We probably need to, at some point in time here, recalibrate our mic. Because I know we've been compensating for this for a while, but usually, boring a block, you leave 3 or 4 thousandths in it to hone out. So this has not been an issue for us. But when we're doing a job here where we have to be just exactly right on the money, that's when your calibration really comes in to play here. That's why we made that first cut.
To find out how close the cutter was.
To find out how close our cutter was. So with that in mind, we're actually going to have to set this a little better than 1.5 thousandths small by the micrometer to get our size to come out where we want it to be. So I think if I set this just a little bit shy of 4.187 by the numbers on the mic, we're going to be right where we need to be. We can always put a sleeve inside a sleeve if something goes wrong.
We've done that, but I don't want to start calling this block what I call the F-all. If you haven't seen any of our early YouTube videos, you should go back, and there's a Farmall H that we went rounds with. But by the time it was said and done, we had a less than nice name for that engine.
But it ran.
It runs.
Yeah.
Ran, we think.
Yeah.
He did have some issues with it.
Yeah, he had some clearance issues between the pistons and the cylinder head, but I think he got it squared away.
It's always nice when you hear it start cutting and you realize that you for sure didn't set the cutter 100 thousandths too big. You just gonna let it run through, or were you gonna check? I mean, at this point, you've done enough.
It's too late now anyway. Yeah, we're committed. Hear that kind of tinny sound though?
Yeah, that's how thin.
That's how thin that cylinder wall is at this point.
Once you get down closer to the bottom of the cylinder where I assume it's supported more, it got quiet again.
Yeah, it starts sounding like it should.
What do you think?
Well, I think it looks like it should.
Any holes through into...
No, there's no holes into the water jacket. Not that that would matter, but it's always a plus if you don't. Let's see how this comes out.
Wow.
I can't believe that.
Check in the middle of the cylinder.
It's good in the middle, too.
That's awesome.
How did we do that?
But with that, we would have 1.5 thousandths press.
Yes. Yeah. With that sleeve will still have to be pressed in place.
But it's thinking about it?
It's thinking about going in. So if I go down to that edge, you can see there we're right at the 6-inch mark, which gives us more than enough room for the bottom of that sleeve to clear. I want to do all the processes on that cylinder before I move on to the next one. Being counterbore cutter, it's just a square blade, cut a perfectly flat edge in there for this. There we are. So with that, I know I'm within 3 thousandths. I can hear it. If you look right here,
stick your finger in it.
Yeah, stick my finger in there and I'll paint it with blood.
Well, you can see that it's just shined up on the front, and it has at least pushed away all of the chips on the backside.
Yeah. So with that, I'm going to zero. And we decided our sleeve is 125 high on the flange.
Yeah.
We want to leave 10 stick up, so let's go 115 thousandths deep.
You did a good job sharpening that.
Yeah, that sounds real nice. Okay, there we are. Normally you need to break this edge right here so that it doesn't bottom out in the radius of the flange.
Well, it's undercut.
Well, that's where I was going with this. Are we going to need to do that? Or are we going to be okay leaving that the way it is because this is undercut? And I'm going to say we're going to be okay leaving that
I think we're fine.
because we have a pretty good size undercut in here.
But I'll look a little closer when I'm not
Yeah.
holding the camera. Set that in there upside down and see if it...
See if it'll even go in. Oh, look at that.
Does it?
Yes. And I feel just...
Move your hands. I can't see that it's in.
Don't look. I have just a little bit of play there.
Our head gasket is going to seal on the top of this sleeve. So even if we did break into water here, it's not going to leak up around into the cylinder or anything because our head gasket is going to seal on top of that flange.
Buy this caliper that is not as accurate as I would like it to be. We probably have about 3 thousandths clearance between this and the top of that sleeve. So we could probably back that off a little bit. Is there any reason to?
I don't think there's any reason to, but
I don't think there is. Let's just leave it. Okay, our first hole is done. Now all we gotta do is repeat that 7 more times.
and again, sometimes we follow what's there, but since we're putting sleeves in, we're going off blueprint
Yeah,
specification.
as much as we can. Okay, there we are, 4.4. There it is, half a thousandth. You can barely see it.
You're going to stick
Catching
your
our-
finger in there.
Haven't yet. Still have them all.
That is really sketchy saying you still have them all.
Okay.
Wouldn't it be nice to have a CNC with a tool changer on it and have all this programmed in and we'd be inside?
Inside
Watching TV while
drinking Mountain Dew.
Yeah. I think it looks nice.
How come that one's much wider?
Because you haven't bored it yet.
Oh, okay. That's nice doing those when you have enough cutters. You can just buzz through.
Yeah.
I guess I'll buy one more.
Okay, so you moved over now 4.4 inches the other direction.
Yeah. Okay, we're ready for cutter number 1.
Counterbore.
You want to do counterbore first?
Well, it's up to you. I just pulled this out so that.
Let's do cut, and then when we cross over, we'll switch and do counterbore first. I don't have to pull a cutter in and out as many times that way.
Well, if there's one thing we're good at here, it's efficiency.
Oh, man. We have just a little bit left in between, so our flange and sleeve does not quite touch. That's going to make it a lot easier. And then speed it up,
Oh, what have you been running?
550.
550? seems like between the cylinders, we're kind of in the as little as 35 thousandths thickness range. You know, maybe upwards of 70 on some. On the thrust side, you're still over 100 thousandths range. So, okay, so now we got to roll over to the other bank.
Take it out, but this is what sets the block correctly, whether you have it this way or whether you have it this way. And I just roll this over to where I think it's close. Wipe the triangle clean, set it back in again, and bring it back against the pan rails. And with that, I now have the block rolled over 90 degrees from where it was, so this deck surface here should be perpendicular to the spindle of the machine. And now I can just go over, put my centering fingers back in the spindle. There, I'm centered.
We decided we're going to keep the y-axis at our 0 point because it should be directly above the crankshaft center line the way our fixture works. As far as the x-axis, you zeroed here. I think over here you were 1.5 thou too far apart. This one you were 1.5 thou too close together, or too far apart also there. And then here you were 5 thou closer than you should be. All pretty negligible.
Yeah. I mean, the way the engine is designed, this direction, your rod can easily compensate for that. Front to back, your piston and wrist pin will compensate for any discrepancies.
Especially in that range of...
Again, we're following several other people that have worked on this, including the factory that may have never been perfect to begin with.
But that said, we're going to use this as our 0 point, and we'll move over our bore spacing just like we did on the other side and cut it.
And we did check the front to back spacing on this side compared to the other side, and we're within 5 thousandths of what Blueprint says it's supposed to be.
Yeah, Blueprint says that you should be 880 thousandths, right?
Yeah, farther forward on the driver bank.
On the center line of your cylinder, this bank should be 880 thousandths, ahead of the opposite bank, and it was 885 here. So again, pretty negligible.
Yeah.
Theoretically, you should touch at 0 on the z-axis. So run it down by hand and see where it touches.
Let's see what happens. Okay, there's 0.
I can just hear it.
Can you?
It is skimming it, just barely.
I think you're imagining that.
There it is.
Oh, there it is. Yeah, I can hear it. 5 thousandths more, or 5/10 more, I can hear it.
You want to apologize for your old man ears?
No. Ready?
But yeah, that's pretty impressive. That's the difference between Chrysler machining and Chevy machining.
Don't go there. You're going to get all kinds of people upset.
Okay.
They all have their problems.
So you need to go to 8.8 on the X. There's a huge hole.
Is there?
Yeah. There's a huge hole in that cylinder.
Uh-oh.
That one did sound thin.
Yeah. You got any bubble gum?
Size is good. Huh. Okay, well, probably show that to the camera. That's why we need sealer. Yeah, that's a big hole. Well, hopefully we don't end up with holes on all of them on this side.
Yeah, this deck surface is really wonky.
So you think that's core shift?
Might be a little bit of core shift, or it might be just the difference from one to another because we are so close to being to the maximum diameter or whatever.
Yeah. You can see the daylight through the... Yeah. So with that, we're going to be relying on our sealer. And if it ends up leaking, we could do that ceramic seal. Turn your flashlight off. Sorry. We're going to make a compilation someday of turn your flashlight off. Turn your flashlight off. But yeah, we could do a ceramic seal on the water jacket.
Yeah. I don't think it'll leak.
I don't think it will either, but
I've never really had trouble with sleeves like that leaking.
I don't see any holes on that one.
Perfect.
Well, it'll be interesting to see if this cylinder breaks through on the right side.
Yeah.
Okay, I don't see anything obvious. What I was noticing, this hole here, there's porosity clear up
above, yeah.
Man, that cut's nice. Final cut?
Should be. Make that last cut and let's eat lunch.
I agree. Ready for sleeves.
Yeah. I see pinholes.
Really?
Yeah.
This side we finished out. This was the first side that we did. And I can't see a single, even a pinhole through into the water jacket.
No, as we've looked through that, if there is anything there, it is not visible to the naked eye.
Now, on this side that we did second, first cylinder over here, that one's just fine. This cylinder, we have a pretty big hole through into the water jacket. This cylinder, we have some small holes, just some porosity. And on this cylinder, I think we have one hole on the side there. It's almost not even visible.
Yeah, when you say hole, you're talking about like slightly larger than a pin.
Yeah, literal pinholes.
Yeah.
We kind of expected that.
I kind of expected that on all of them,
Yeah.
honestly.
So we're happy that we came out with 5 cylinders that we don't think we have a hole through.
Yeah.
But that being said, we're going to install all of our sleeves with the sealer just to be safe anyway. But it looks awesome.
I'm impressed.
It came out really good.
Yeah, that worked very well.
Fresh morning, fully recovered after getting home at 1 a.m. from 21 Pilots.
And me staying up till 1 a.m. watching your kid.
Yep.
Helping mom watch your kid.
Picked up liquid nitrogen on the way here this morning, $140 worth. You know, people wonder why we don't always use liquid nitrogen.
Right.
It's expensive. It's dangerous.
It's time consuming to go get it.
It's just not worth it for most stuff. So the block is in the oven right now on the other side of the shop at about 300 degrees.
Right.
And I put the bore gauge in, and that thing already has expanded enough to give us 5 thousandths clearance on these sleeves.
Okay.
I think by the time we put these sleeves in liquid nitrogen, we're going to gain another 5.
Probably so.
So we're probably going to be in the range, a minimum of 5 thousandths, if not closer to 10 thousandths clearance. Plan is set the block here, run a 1-inch band of green Loctite around the bottom to seal it,
Right.
and retain it.
Yeah.
Hopefully drop the sleeve in. Then we've got the hammer and the driver ready to pound
So
it.
if it grows on us and raises up a little, I can hit it a lick there to get it back down tight to the flange.
Because it'll equalize temperature almost immediately once it's in. And hopefully, you know, if it moves up, you'll be able to seat it with the BFH.
Yeah.
So let's pour some nitrogen into our igloo.
That's about enough.
Okay. So drop that sleeve in carefully. Don't stick the glove in it. So this bore gauge is set to the 4.190 that our sleeves are at room temperature. Yeah, you got five or six there.
Yeah. Yeah.
So we got plenty.
The cleaning guy's nervous.
I'm nervous too. Ready?
I'm ready.
Okay.
Sounds pretty solid to me.
So it's solid.
It's solid. Listen to it the way it
Rings.
that's solid.
Okay. So none on this bank had any holes through the water jacket, but we still want to use the sealer just in case.
Right.
We got 3. Whew. We don't get a lot of excitement here in the shop, but when we do, it's real exciting.
It doesn't take much to get us going. Oh, man. That's solid.
Get your side a little more. Ooh. Now look how long there.
Keep rotating it.
It
just now stuck.
It's there.
Okay. It's solid. Yeah, the frost stays in the middle longer than on either end, but then there's no cylinder wall.
Yeah, there's nothing to heat sink.
No, not much left there on either end.
And then we're gonna go back in the oven for the other bank.
Yeah, let's put the block back in, warm up, and kind of regroup here, get some more liquid nitrogen in the cooler.
Okay, you ready?
No.
Okay, I thought you were ready. Hurry.
Go for it. Huh, that's pretty cool.
See, there's more time than you feel like you have, but what happens is you get it kind of wedged, and then it instantly starts warming up, and you're screwed.
Once you make that good solid metal-to-metal contact, the heat starts really transferring. Now, that first time I hit that, I'd say it moved just a little.
You think so?
Yeah.
You know, in the movies, like, when they're like, doctor, doctor, doctor.
That went well. So let's get it back in the oven. Give it a few minutes to kind of come back up to temperature.
How's it look on the bottom?
I think they came out right where I was expecting them to.
Yeah. Again, remember, these two have pinholes. This one honestly has a pinhole all the way about halfway up the cylinder.
Okay.
As does this one with the very big hole.
Okay.
But be careful with that dauber on the...
Yeah, and we're
starting
doing
on this one.
We're doing number 1 right now, right?
Yes.
It's one of them deals where you feel like forcing it,
but you know you can't because it'll...
Right. It grabs even harder.
Sounds solid.
Yeah. Make sure it's done boiling.
It is. I was going to try to rotate it a little bit. Oh,
Try again. There you go. You piece your glove under.
How'd I do that?
Oh, I see it.
Is it all right?
I think it'll be. It's just in the
Counterboard, on the side of the counterboard?
Yeah. We'll be able to tell when we measure it.
Yeah. Why am I struggling?
You're not getting straight. You're leaning a little bit too much. There you go. You were leaning over towards me, and
Well, I kept my glove out of that one.
don't lean my way too much. Who's squeaky?
Me.
I'd say we're there. Let me measure it once. That's really something how far that was off.
Yeah. It doesn't look like that's up at all, so I think you're right. It just got the edge of my glove
Edge of your glove.
on the edge of
I
the.
don't know, when you went down in, did it, piece of your glove was kind of hanging?
It was kind of hanging under the flange and cut it off. You can see. Oh, jeez. Could have been a piece of my skin.
You're lucky. I'd say we're done.
Looks good from up here anyway.
Yeah, I'm excited.
I'm ready for lunch.
Yeah, it's lunchtime.
We maybe could have been just slightly shorter with our sleeves, but I think we're in a fine spot. We may have to come up with some kind of almost a line bore tool that we can use to come in and trim that off. We could just grind it by hand, but
Yeah,
we also like to have fun around, so waste some time. And
well, I think we can do a lot nicer job if we can come up with a kind of a makeshift line bore.
we have a stroker crankshaft for this.
Right.
So it's actually even a little bit, I don't know if the counterweights on that are longer, shorter. I don't know where they're at compared to a stock crank, but regardless.
This would have to be trimmed even if it was stock crank.
Yeah, so that's what I'm saying. Regardless, we got to trim it.
Yeah.
But for now, let's deck the block and let's bore the cylinders for, our standard size.
Take it back to standard size.
We're starting on this side of the deck because it is kind of wonky.
Yeah.
It's actually tilted a little bit. I made that comment about the difference between Chrysler machining and Chevy machining, and I guess I got
bit you.
Yeah.
Yeah, it bit you because some of the same Chrysler people were working on this Chevy.
So we're expecting when we start cutting, it's going to cut heavy over here. Theoretically, our cutter should cut across the sleeves all the way across when it touches.
It'll start cutting on the sleeves pretty square, and then gradually, it'll start cutting on this side of the block, and then as we take more material off, it'll find clean up over here. We probably will end up maybe not cleaning up all the way here as far as this one is off. We may stop right here so we can preserve as much deck height as we can. I know we can make this seal up even if it is a little bit low.
We're either going to have to order custom pistons or we're going to have to modify a set of pistons to make this combination work. So at that point, I don't know that a few extra thousandths makes a difference.
But it was a deal. Our thought process was to preserve as much deck height as we could.
Yeah. Keep it for the next guy.
Yeah. So let's touch off on the top of the cylinder itself. So you can see here where I've touched off. There we go. That'll give us a little more light. Touched off on the top of the sleeve. I'm square, touching both sides.
Yep. But yeah, when we get to actually touching the deck, we're expecting it to touch here and not here, but our sleeves are square, and that tells you that our setup is square to what we had it set up like yesterday.
Yeah.
Because our sleeves were installed square to the machine.
This block is far enough off, it actually made me nervous that, gosh, do we have a mistake in our setup? But it's not.
Okay.
It's just that far off.
So we're going to take a 5/1000 cut.
So what does it look like?
I'll let the cutter turn off and I'll tell you. It cleaned up more than I thought it would. So we cleaned up all the way across the sleeves. We need to oil the table probably,
Yeah.
because it's a little chattery there.
The deck is high on this side and tilted.
Yeah.
Whatever they did on that factory, they cut one end high and at the wrong angle.
Yeah.
And amazingly enough, the thing ran.
Go figure. Yeah, but we're not quite there. And we still have this over here.
You know, the rest of it's looking good.
So where are we relative to factory? So we're probably 9020 and 9025 is factory. Let's take 2.5, see what it looks like, but I'm still gonna run fast.
Okay.
And then maybe I'll take 2.5 more. That would put us 10 under factory, which is not a crazy number.
Okay, that's fine.
That's dang near got it.
Say what?
That has dang near got it. So let me check one more time. If we do 2, we'd be about 10 short of factory.
Okay.
Oh,
That'd be a good number.
because I'm getting an 8 short right now. You got it. Thought I'd run the profilometer across it. 16.
Yeah, that should be good.
So 0.
Yeah, I would call that my 0.
Okay. That way when we roll over, we can deck to the exact same point on the Z-axis digital readout, have the deck heights exactly the same.
Yeah, that cylinder that's marked 00 there, number 3.
Well, it ain't marked anymore.
Oh, okay. It was till you decked it. Anyway, I think that's the one you start with to reference off of for boring.
Center up on this one,
I
0
would-
axis,
And then 4.4 center line,
all directions.
down the line, all directions.
We got to take about 110 thousandths out to be to finish size,
Yeah,
but we want to leave 5 thousandths to hone in the cylinder hone
Yeah.
with the torque plate. We have 2 cutters set up, one to bring it within 25 of finish size,
yeah,
and then this finish cutter will bring us within 5 of finish size to leave us some meat to hone, and then we have a chamfer cutter.
yeah.
Okay, centering finger, running in the sleeve. These are kind of hard to get centered up, but that's about as good as it gets because that sleeve is probably distorted a little bit after pressing it into place. Plus, they're a really rough finish.
Well, I think it's more the rough finish in them than anything else.
Zero our X and Y now. And when we move over, we'll go 4.4, 4.4, 8.8, and we'll just go through and bore it.
Yeah.
Cutter number 1. Cutter number 2.
I'd probably go
You think that's enough?
maybe just a little bit more to allow for honing. Stop.
Okay, 50945 or 5095. .095.
These 850s,
Good.
you got plenty to hone.
Yeah. Cutter number 1. Cut number 2.
You ought to put something in there somewhere that your buddy Dave sold you those sleeves. And he told us this was the ticket to making a hot rod.
Our buddy at ECW, Dave?
Yeah.
Okay, now let's switch over and deck it. This is the part of the video that the guys who are worried about these, 8 numbers right here, need to turn the video off.
Yeah, because you're going to lose it. Because
Just go watch a different video.
Yeah, let's go watch one of our other videos for a little bit. Because this is going to really upset you. And me personally, I don't even care. Numbers make no difference to me. Oh, yeah. Definitely cutting there. 5 at a time, or how much? By
By numbers.
Did you need to write them down before we start?
I have a picture of them from the old video.
Okay. Just in case somebody should want to see those.
So did that touch the deck anywhere?
I don't think so.
Well, I guess it did skim right here, actually.
I sure did.
And we have these flaws from the factory that were welded up, so we'll see how those machine.
At some point, we ought to knock that little blob off there.
Yeah.
Okay, let's give it 5 more.
You know, those numbers may still show when we're... Apparently. Well, they're probably not going to show, actually. I thought if it wasn't going to touch on this pass, I thought they might still show, but I don't know, maybe not.
If they're stamped deep enough, they may still show. That was funny just as soon as you said that.
Yeah.
And then we need to remember to chamfer some of those. It looks like part of the issue with this block is it shifted from the pan rails.
So I don't know how well the camera sees that, but we're about halfway across.
Yeah,
cleaned up.
It's machined from here over to there, there,
Low spot
there.
here.
Yeah, there's definite low spot there next to that weld.
Okay, we are 5 below
Or
factory.
Five below factory, but we ended it.
We're a strong 5 below factory. On this side of the deck, we ended at 10 below factory.
Okay.
So I would take this to 3,
Okay.
and then we do a 2 thou finish pass, and hopefully we clean up.
Sounds good to me. I'm as much worried about that spot as I am anything else.
But
Well, it won't matter because
don't
our
matter.
gasket is going to seal on the flange of that sleeve, so we're okay anyway.
2.
Huh.
So who did that?
I thought where this had been filled in here was
Are you even cutting right now?
No, or cutting if you want.
Yes, please.
I thought this was a factory repair where you see them repair castings sometimes, but this looks like you can see, is that file marks or grinder marks? What is that in there?
Maybe.
I'm surprised that would have looked like that from the factory.
Just has hoop-de-doos all
Yeah, it
through.
does.
It's gonna be close. I would take the 2 and call it good.
Well, here goes. Well, I'm very happy with the way that came out. You get it? Leave that off.
So what'd you say we decided? This is like boring 8 blocks?
4
4 blocks? Because we did 2 cuts on each hole to prep for the sleeve. And then we did
counter bore.
and a counter bore. And then 2 cuts on each hole once the sleeve was in.
Yeah. Yeah, that's why it feels like we've been here all day.
2 days in a row.
Yeah. Camera out of the way.
Yeah. You got a little bit of pitting around some of those, but
That's not going to matter because there's an open area in the head.
okay, that's what I thought.
Runs water up past I think kind of past the spark plug.
And all that weld machined
Yeah,
fine.
that machine nice.
That looks great.
It actually really does look great.
I'm really happy with this.
Very happy.
8 sleeves. This block is actually starting to be past the point of no longer being scrapped.
Right. Yeah.
I don't think there's anything about this block. Well, we don't know how bad the mains really are, but that's
But regardless, we're going to do a line hone on it, and there was nothing wrong with the mains before, as far
Theoretically.
as anything. Yeah, well, yeah, there's no spun bearings or anything like that.
No.
Nothing couldn't be repaired. But now we've got a whole bunch of work on the bottom side, cleaning up the bottom of those sleeves, and I think we both want to do more than something a little more professional than just going in there with a hand grinder.
yeah.
Could be done that way. Probably would actually be quicker. So let's take some time and
Think that through.
think that through. And I'm going to say stay tuned later for a follow-up video on this, and we will build ourselves some sort of a line bore tool to go in there and cut the bottom of those sleeves and make it look factory.
Yeah. Machine it for our crankshaft. Because,
Yeah.
again, we don't know if our aftermarket crankshaft is bigger counterweights or anything. So we really kind of need to build that tool and kind of mock it up at the same time for our stroker. So I think we're in a good stopping point right now, though. So let's call it and
Let's call it, and
stay tuned.
we'll see you the next time.